In this final video covering window functions, we're just going to be looking at two window functions called lag and lead, which are useful for retrieving values from rows before or ahead of the current row when ordered in some particular way. And using these window functions is a simpler way to deal with the next and previous type questions that we dealt with earlier with very complex self-joins. Lag can be used to retrieve values before the current row, while lead is used to retrieve values ahead of the current row. And both lag and lead ignore window frames, so you don't have to worry about those like you did with aggregate functions. You establish your window with the partition and order by clauses, and that's it. Let's dive in and take a look at an example. We'll start off by using the lag function, and what we'll be doing is looking back for each customer at their previous rental. So we're working with the rental table. And for each rental, we want to select the rental ID, the customer ID, the rental date, and we also want to return for each rental the previous rental from the same customer. We can use the lag function to do this. So we'll say lag over, and now we establish our window, which is all the rentals from the same customer. So we partition by customer ID, and we want to order by rental date. The argument that we now have to pass lag is where we specify what value or what column we want to be returned from one of the previous rows. In this case, we just want to obtain the rental date because we want to obtain the previous rental date from the same customer. Let's put a semicolon here and let's run this query. What the lag column represents is the date of the previous rental from the same customer. So starting with customer 1, this was their first rental on the 25th of May 2005, and there is no previous rental, so the lag column simply contains null. For the next rental from that same customer, what the lag column contains is the date of their previous rental, which was the 25th of May. And so on for each of the different rentals, we're able to obtain the date of the customer's previous rental. And that continues on all the way for every single customer. We start again. So again, for the first rental from customer 2, the date of their previous rental is null, and thereafter we get values. We only provided one argument to lag, but there are actually two other optional arguments that you can pass to the lag function. The second argument, which is optional, is the number of rows to look back. By default, it's 1, and so the lag function will return the value from the previous row based on the ordering of the window. But you can change that. If you want to look back 2 rows, you can specify here as the second argument. Let's run this and let's see how that's changed things. Notice now that lag is looking back 2 rows. So on the third row for customer 1, that's the first time we see a value. That's looking back to the first rental. From the fourth rental, it looks back to the second rental, and so on. And this is also why the first 2 rentals are null, because if you look back 2 rows, there's no rentals to refer to, and null is the default. And that's the third optional argument that you can override if you want. By default, if there's no corresponding row, the value that gets returned from the lag function is simply null. However, you can override that if you want and specify a value, some other value to be used instead of null when there is no row available. Instead of getting a null when there's no corresponding row, let's instead choose to return the Unix epoch date, which is the 1st of January 1970, and we have to make sure we cast that as a timestamp so that it matches the type of whatever value that we're trying to obtain here, which is also a timestamp. If we now run this, we'll see that in place of null, we now have this timestamp, this default value that we chose as a third argument. So lag allows you to look backwards, it lets you obtain values from previous rows, and the corresponding function is called lead, and lead will let you look forward, it will let you look ahead for rows. Let's use lead now to look forward. And so we'll look at the next rental date over the same partition, and ordered by the rental date again. And if we now run this, we can see that in the lead column for each rental, we were able to obtain the date of the next rental based on that ordering. And if you go to the last rental then from customer 1, we find that the column value contains null And that's because this is the last rental within that partition that we've defined. This is the last rental for customer 1. We've covered some of the most common window functions that you'll get exposed to, but there are some other window functions that are available that we didn't use. Now that you're familiar with and understand how to use window functions though, it will be easy for you to read the documentation and try out some of these new functions on your own. If you're interested in them, just go to the Postgres documentation site and search for window functions and you'll come up with this page. You'll see that we've looked at row number, rank, and dense rank as the ranking functions. We looked at different aggregate functions, so sum, count, and average. They're documented on another page. There are some other interesting functions here that can be used if you're doing some statistical work. There's %rank and cumulative distribution and entile. Entile can be quite useful if you're doing things where you want to establish buckets. For example, if you're creating histograms. We've just now looked at lag and lead. And in addition to lag and lead, there's 3 other interesting offset functions: first value, last value, and nth value. First value says it returns the value evaluated at the row that is the first row of the window frame. So if we jump back to our code for a moment, if we wanted to give first value a go, let's try it here. And we'll do it over the same partition. Let's run that. And if we look at the results, we can see that what first value has obtained is the first value within that partition. So for each customer, the first value is the date of the first rental they made, the 25th of May, 2005. And that's the case for each customer. So when we move on to customer 2, their first rental was the 27th of May, and now that's what that column contains. One thing that could catch you out using first value, last value, or nth value though, is that they do actually consider the window frame. With first value, last value, and nth value, they consider rows within the window frame, which by default consists of rows from the start of the partition through to the current row. So often you'll find yourself when you're using first, last, or nth value needing to go in there and manually override the window frame, as I showed you in the last video, to consist of all the rows from the current partition, not just the rows up to the current row. Jump in and have a play around with some of these different window functions. In particular, you may want to experiment with entile just to see how that works. And when you're ready, we'll be jumping over to our final chapter on querying SQL, which is going to be covering set operators. It's a much easier chapter compared to this one, so it will be a nice, easy way to finish things off before we move over to looking at how we can write data modification statements to create tables and to insert data into those tables.